So, good afternoon, class. In your previous class, I have already completed the total fault classification and the what is fault and its different types I have already covered. In today's class, we'll be learning that how you can recognize a fault in field. Okay. So today's topic will be recognition of fault in field. So generally, structural geologists they do they go to the field and they basically measures the attitude of the exposed rock. That's the common way to do the structural mapping. Along with that, you will be seeing several other points, you will be seeing several other evidences in the field to find out a fault zone. Sometimes faults are defined, it's very visible. I have shown you several photographs that faults are faulting zone or the fault plane is visible from one side. But most of the cases, this fault plane will be covered by some vegetations. It may cover by or it may not appear like the fault planes we have seen in that photo in those photographs. So directly or indirectly, you have to identify the fault after having some evidence of that region. So what are those evidences? So the criteria for recognition of fault in the field, it can be divided into three groups. What are those groups? First one is your geological evidences. I'll discuss what are the geological evidences. Then I will discuss what are the fault plane evidences you can count on. And third point would be your physiographical evidences. So these evidences will be seen clearly from a distance or by some satellite imagery or by some drone shots. So these physiographical evidences will be discussed. Now let's discuss about the first one, that is the geological evidences. How you can recognize a field by seeing the geological proof or geological evidences. So the geological evidences are seen very clearly on geological map. You will be plotting the attitude of the beds and that structural geological map, and you will also be writing the corresponding information that this point this type of rock is found, this point this type of strata is found. You will be naming those stratas. I'm not going details of that, but the most important geological evidences of faulting are the offset of rock units. So first, let us understand what is offset. This is the fault plane. That's the footwall. Okay, and this is our hanging wall. If I draw it in a 3D, you can understand. Or it's like this. Okay, so this is the hanging wall, and this is the footwall, and this is our fault plane. This is our fault plane. Now offset means this point and this point was initially intact. This block has an offset of this amount, means the distance between the previously intact point. So after faulting there will be a displacement. It's called the offset. So this region, so let's draw a marker here. Suppose this is the marker bed. That marker is here. So that marker should be in this position. But instead of is having in this position, you are having the marker at this position. So that's the offset. That means displacement of bedrock, displacement of rock beds or any dike or veins, etc. occurs on the opposite side of a fault. Is by seeing this. This is the very common and this is easily understandable that by seeing this offset, you can say, okay, this plane is the fault plane and this is the offset value. Okay. Another important point is the repetition and omission of the strata. So if I will look for, I will look for the offset of the rock units. If it's not visible or it's not understandable, then I will go for the structural mapping, and there I will be seeing the repetition or omission of the strata. Let me give you one example here. Okay, so suppose a sedimentary rock block before faulting. So this is the condition for before faulting, and this is the, suppose this is the sandstone, okay, but sandy layer. This is the this is shale, and again this is the sandstone layer. So obvious reason before faulting, what happened? This is the okay. So this layer should be the older one, and this is the younger one. It's clear now. If there is a oblique fault, if the oblique fault you are find here, if there is a fault or the deep fault is there, then what will happen? This side of the block will go down, this side of the block will go down, and it will look like okay, like this. So this is the sandstone, this is the shale, and this is the sandstone. Here this is the sandstone, this is shale, and from this figure, after faulting or after the creation of fault, this is shale and this is again sandstone. Okay, or let's say a host and graben structure is also there. So consider it's a graben like structure. At this point, let's consider this, or let's not consider this. सिंपल ही रखते हैं इसको, कॉम्प्लिकेशन नहीं करते हैं. Okay. Now let's suppose for some reason this portion of this block got eroded for some reason, and now this is the surface of the earth on which you are walking. So you are walking from this side to this side on this surface. So what type of rock you are encountering? First you are encountering shale, second you are encountering sandstone. If there is another type, if it's a graben like structure, host and graben like structure, then there again you will be finding shale. So it's a host and graben like structure, then you will be seeing the repetition of strata. Otherwise what you are seeing, that this portion this portion should have the shale part. If it's a continuous strata, it's an abrupt truncation is happening here. So that continuous of strata here, this portion is missing. So there should be a shale structure here, or there should be a sandstone structure here in this side. That's not happening. So repetition and the omission of strata, by seeing or by doing this structural mapping, you can understand that this is a fault structure. Okay. Now abrupt termination of structure is also an indication of the fault structure. Like in any fault plane, see here, initially this was the continuous strata. After faulting, what happened? Sandstone layer got abruptly terminated. Okay, shale layer got abruptly terminated at this boundary. Sandstone layer got abruptly termination. So this abrupt termination of strata or dike or bedding planes or lamination, this type of abrupt termination of the feature of sedimentological feature, such termination of structure along their trend is usually caused by deep and diagonal faulting. So the lost portion of the structure may be, so what happened most of the cases, lost portion of the structure may be, so suppose a normal faulting has happened, we are seeing only this part, okay, on this top we are walking in this case, and let's say this portion got filled up by some loose sediment or some river sediment or some alluvial. So this structure exists and it exists at certain depth, but you are not seeing it. So if you walk on this surface, you are first encountering, you are getting sandstone, but as that sandstone got abrupted at this boundary. Now if you dig up to a certain point at shale, okay, so you are having the shale, and shale is also truncated at this boundary. So what you will be saying? You will be saying that this plane is our fault plane. So it's quite obvious the rest of the portion or the other block undergoes or other blocks subside underwater, or may submerge in underwater, or the alluvium, the river sediments, or it may be concealed under the lava or younger series of rock. So there might be another type of sedimentary rock you can see. Okay, so these were the original blocks, but this portion or this space is occupied by a younger series of rock, and that's quite common. So abrupt termination of the structure is also indication of your fault. Now strata out of stratigraphic sequence. What do you mean by that? So what is a stratigraphic sequence? Means the layer after layer, the arrangement of the sedimentary layer after layer is called the stratigraphic sequence. Suppose at the top layer you have sandstone, then you have shale, then you have limestone. Okay. So this sequence is called the stratigraphic sequence. If you dig a borehole here, like a geological drilling, then you will have this structure, that at the top you have the sandstone, then you have the shale structure, then you have the limestone structure. Now if this block of rock goes or undergoes a certain type of defaulting, this type of faulting happen, and let's consider for this case or for the simpler case some reverse faulting has happened. So what will happen? This block will go up. So this type of rock is the older rock for obvious reason, and this is the younger rock. Okay, if this thing goes up and reverse faulting happens, so this is actually the older rock, this is the younger rock. So above younger rock you will have the older rock. Okay, if this goes up after faulting, I'm drawing, so you will have the older rock, then you will have the younger rock. So above younger rock, if you are encountering with the older rock, so you can say this is not the actual stratigraphic sequence. Stratigraphic sequence tells you that bottom one will be the older and this one will be the younger, but that thing is not happening here. If you are seeing when the older strata occur above the younger strata, that means कुछ गड़बड़ है, कुछ तो गड़बड़ है. That means this not in the order. The stratigraphic sequence is not in the order. So the normal stratigraphic sequence of region may be disturbed for faulting when the older strata occur above the younger strata, and this signature gives you the idea of faulting, and you may consider, is this a fault, that's why it's happened. But not seeing or not getting only one evidence, you can say it's a fault plane or anything. So you have to consider all these possibilities, and then if you got, if some of the possibilities comes out right, then you can go for the conclusion that it's a fault. Now abrupt change in the altitude of the or attitude of the strata. So what do you mean by attitude of the strata? Attitude means deep and weight. So that's the common way to identify the fault zone. When the strike and tip of the strata suddenly change, the faulting is indicated. That's the common concept, and that's the ancient concept, that's the old concept you can consider. So this is the 5 evidences falls under the geological evidences, and you will be looking all of them. Not so every time you can see the offset of the rock unit, not every time you can see the abrupt termination of the structure, but कुछ तो आएगा ना, some conclusion you might get if you experimented or if you go to the field keeping this point in mind. Okay, now second type of evidences is your second type of criteria is fault plane evidences, and this is very important. So see, the fault plane could be off. In my last class I have told you that fault plane could be off few meters or few 100 meters to few kilometers. So it could be up to, let's say, 5 kilometers. The fault plane or it's come around if in the order of square kilometer. In the order of the area, if I talk the area, then area is coming in the order of square kilometer. So it's a huge place or huge site you have to identify, and there in the fault plane area, so the fault plane evidence includes the minor structures which are found associated with the faults. So this area may be covered with vegetation, they might be covered with some signature, and in this section or in this part we will be looking for that signatures. So first one is the silicon site, this one. So what do you mean by silicon site? Suppose a large block of rock is dragging on a plane. Okay, so due to the gravity, two things will happen. One will be the plane will be polished, it will be smooth, the fault plane will be smooth. Okay, suppose this block is dragged over this fault plane, so two things will happen. One will be the fault plane will be smooth, another will be there will be grooving marks, there will be dragging marks, there will be stretching marks, and that grooving marks will be kind of a deeper marks, let's say 1 feet 2 feet deeper or more than that. So these grooving marks will be there because this block, the hanging wall block, is not smooth as I'm drawing. It is a rough surface, and two rough surface has a just like the frictional or the friction. In your physics class you have read friction and all that block, that experiment. Okay, now consider that surface is not that smooth, but the block is going downward in the presence of or in the action of gravity. Due to the gravity is going down. So what will happen? It will smooth out this plane, along with it will leave some mass. That grooving mass is so deep, it could be 1 meter deep up to, let's say, 1 meter to 2 meter deep. So that deep, sometimes this deep is filled up with some chemical precipitation. So it could be filled up with some, like, let's say, some placer deposits like gold, or it could be filled up by some minerals. So this is silicon side. So if you are inspecting a fault plane, then you should go for this concept in mind. See, is there any silicon side are present? So silicon side are useful in knowing the direction of the latest movement also. By seeing this grooving mass, you can understand, and the mineral deposits, by seeing that you can also understand that the silicon sites are commonly associated with fault and are formed along the fault plane. So on the fault plane you will be seeing this kind of structure, this silicon site like structures. Second point is your drag. So what's happening here? This block is coming down. Okay, this block is coming down in this direction. So जिस प्लेस पे ये आ रहा है, then there you have to keep this block a space, otherwise ये कैसे आएगा? So what happening here, when this block is coming down, it's making a space in the immediate vicinity, so that by doing so क्या हो रहा है, इसके नियर बाई में एक फोल्ड जनरेट हो रहा है. So what's happening here, when it's coming down, it's basically repelling the existing material at this position. And what's happening, the air is forming in the immediate vicinity of the fault. The end of the strata may be bend up, or it may bend down. Okay. So if you are keeping this block in this position, then this strata will be bent. This type of fold is this is a folded like structure. This local bending is developed and is called the drag fold. So the local bending which is caused by the fault displacement is called drag. So it indicates the direction of movement along the fault. So it basically indicates the direction of movement along the fault. Okay, this is also an indication of fault in the field. Now there is another one, that is the Brachia gauge. So Brachia gauge, along some faults, the rocks found highly, it's a heavy block. It's a very heavy block. Okay, it's coming under the influence of gravity, due to the gravitational pull, or due to the gravity, it's coming down. And for this reason, what happening in the way, it's not a smooth surface. So whatever I am doing is looking like a smooth surface. The surfaces are not smooth. So what happens if there is a large chunk of rock in the way of this going down? So if there is a large chunk of rock in the fault plane, so what will happen? It will crush it. So sometimes you have read this in the very beginning of fault. I have discussed that it could be a shear zone. You cannot identify a simple or a single plane. Or it's a simple plane, you can identify the fault. Okay, it could be a zone of crust rock. So that thing happened here, and most of the cases you will be seeing the angular fragments or finer grain-like fragments. Two things might happen most of the cases. So this angular fragment is called Brachia. This clay-like fragments is called gouge. So along some faults, the rock are found highly fractured and crushed to the angular fragments. That fragments is called the Brachia. So these are also an indication of fault plane. Now for the silicification and the mineralization part, this is also very interesting, that here the water comes into the play. Water. Suppose there is a fault plane. Here I have discussed that there is no gap in between. It may look like, or let's say there is a net slip. Consider a oblique fault to understand this point. Okay. And this fault has some space in between the hanging wall and the foot wall, like this. The space is there, and this thing might happen, or due to the uneven surface. This surface is uneven, this surface is uneven. There may be gap, and water may percolate through this gap. So two things happen generally. One is when water is passing through this, and this zone may deposit fine grained quartz Okay, or this zone may deposit some chemical due to some chemical precipitation. Minerals may be deposited. Let's say golds are deposited. Okay, I'll show you some photograph that at some fracture place there are gold veins are there. It's called actually called the gold veins. So in that veins the placer deposit like golds are deposited. So this silicification and mineralization is also a indication of the fault plane. Then there is a feather joint. So this is developed due to the tension, and when a large faulted area is developed, or large fault zone is developed, or large fault plane is developed, and feather joints are the tensional fractures formed due to the fault displacement. Due to the fault displacement, what's happening? The surrounding will be having some thinly fractured area, and this is called the feather joint. So these are also a indication of fault or fault plane. Now, for our physiography, or the third evidences type, we'll be looking at the fault curve, fault lines curve, and offset ridge. What is curve? Curve means the steep straight slope of a ridge. It's called fault curve. Now, fault lines curve, that means when in the physiographic evidences, you are looking the evidences from a distance. You came back to such a point that you can see entire fault plane, let's say, or you are using aerial photography system, or you are using the remote sensing system or the satellite imaging system to see the structure. So scarp is the steep straight slope of the ridge, and fault scarps are the scarps formed as a result of faulting. So they are found only in those areas where the faulting has been geologically very recent. So if you are seeing this kind of signature, that means the faulting is recent. There is another option here that is called the fault lines curve. So the fault plane I was drawing smooth one, but in general the fault plane will not be a smooth structure. Okay, so there might be a chunk of rock in between them. So this chunk of rock look like this forming a ridge in a fault plane. It's called the fault lines curve. So this curve is called fault line curve. Then there is offset ridges generally formed when the resistant rock walls are displaced along the fault. Then fault controls of streams is also there. So people generally do a drainage pattern mapping from the aerial imagery, from the satellite imagery, drainage pattern mapping, or lineament mapping, whatever. So this drainage pattern mapping, you might have heard that river flows through the fault line. Most of the cases, through fractured or through fault line, river generally flows. So fault basically control the flow of the stream. So by seeing any signature like this or seeing the pattern or seeing the network of the signature, you can identify the main fault zone and the feather fault zone. Okay. Another one is the lines of the water bodies and all. So linear arrangement of ponds, spring, and water seeking plants may also be an indication for water bodies. So why these faults and folds are very important. So the up to this is your false recognition in the field part. Now why you should read about this? As a mining geologist, it has a huge implications, like the several mineral deposits you will find in between the fault, in between two blocks of a, or in a fault area or in a faulted area, you will be seeing some mineral deposits. As a civil engineering student or as a civil engineer, what you will be looking after? If any rock structure among which you are making a building, okay, so you should be considering that this building is not फ्रैक्चर तो रहेगा लेकिन इसका ज़्यादा फॉल्ट नहीं रहे, ये तुम्हारा ऑब्जेक्टिव रहेगा. सो यू हैव टू लुक आफ्टर दैट not much of fault lines or fault planes are there in that rock. This is not structurally deformed. For this reason, this fault and fold study is very important. Now, so you will be reading these things, this for recognition of fault in the field I'll be sending you a study material. From there we'll be reading this in details, because you have to, in your exam you might have to write in details. So read this in details, okay? See the gold deposit, it's called the vein deposits. Now lineation, linear structure of different types are also called lineation. So this linear structure could be any bedding planes, the linear structures could be any fracture plane, anything could happen. Any linear straight line structure like this pattern, this is also a linear structure. It's called the lineations. Now last topic of this chapter of the structural geology is the unconformities. So what do you mean by unconformity? Suppose there is a sedimentary rock or sedimentary deposition happening here. So layer 1, layer 2, layer 3, layer 4, okay? And this rock obviously, or this strata is the older one and this is the younger one as for now, okay? And suppose these depositions are happening at 100 million years ago, okay? So at this point the deposition stopped at 100 million years ago, and for some reason deposition doesn't happen as for now. As this point, consider the deposition is not happening for some reason. River channel might be changing its direction, or anything can happen. But later, by some reason, the deposition of sediments are happening again. So these are forming the sedimentary rocks later. The deposition of sediments are happening, okay? So these layer depositions happened, suppose at 110 90 mm, means 19 million years ago. So 100 million years ago and 90 million years ago. So there is a gap, and this boundary I am marking is differently. This boundary is giving you the idea. This is the boundary where the break is identified, or which basically gives you the idea of the time gap between the sedimentation. So this layer A and this layer B, there could be the consecutive layer, but there is a time gap of the sedimentation is called, this thing is called hiatus or unconformity. This is unconformity plane. Now another case could happen. ऐसे deposition होता जा रहा है, the depositions are happening following that criteria, and at some point the sediment accumulation stops, let's say, and this top portion of this, the top portion of this feature or this sedimentary sequence got so this top portion got eroded, this one, okay? So suppose at 150 million years ago, up to 150 million years ago का जो sediments था वो वहीं रहा, बाकी सब उड़ गया for some reason, okay? Now again after some times the depositions are happening or sediment accumulations happen. So there is a time gap here. So this layer is basically posed as the time gap layer. It's a boundary between two different timelines, okay? So the major break in the sedimentation is called unconformity. So when the sedimentary rock beds are found to have been deposited without interruption, when it's deposited without interruption, then we'll be calling it a conformable bed. So unconformities are formed when there is a break in the sedimentation. That's very important. This creates a gap in the geological record. This creates a gap in the time. This creates a gap in the geological time of sediment accumulation. So this is called the unconformity. So generally an old erosion surface which separates younger series of rocks from the older series, okay? Now it can be of three types: angular unconformity, disconformity, and nonconformity. So what is angular unconformity? So unconformity is generally old erosion surface, and the characteristics of the erosional surface is that it abruptly truncates all existing structures. Like this is a nice folded structure like this. This folded structure was there, and this XY unconformity plane, this is the erosional surface, is abruptly truncated this structure. See, this structure got truncated at this point. Okay. So in case of angular unconformity, what happened? On either side of the rock beds are not parallel. Rock beds on the opposite sides are not parallel. This is folded, see, and this is parallel. This is a horizontal strata, and this is the folded strata. So these rock beds and these rock beds are not parallel. Then I will be saying it's a angular unconformity. In case of disconformity, the rock beds on the opposite sides are parallel, like this. But you can identify the unconformity line how? See these darker shade strata or these dotted strata, they got abruptly truncated by these erosional surfaces. This XY surface is abruptly truncating the existing structure. Both the layers are parallel, but you can identify the unconformity here. Non-conformity में क्या होता है? Non-conformity basically deals with the igneous rock and the sedimentary rock. Consider there is igneous rock at the bottom, and above which some sedimentary or sedimentation happen. Sedimentary depositions happen. Later a rock is formed. Okay. Then this type of mismatch structure is called non-conformity. So when the bedded sedimentary rocks overlie the non-bedded igneous mass, then this boundary will be called as a unconformity. Sorry, this boundary is called as a non-conformity. Okay. So this is when neither one is parallel. When opposite sides are not parallel, then angular unconformity. When it's parallel, it's called the disconformity. When it's igneous and sedimentary, it's called the non-conformity. You have to remember that. So how can you can identify the unconformities? So you can identify the difference in structure, like the group of rocks on either side of an unconformity may show structural discordance. How you can identify? The top layer will be different, the bottom layer will be different. Difference in the fossil record, difference of the presence of the conglomerate, fossil soil, difference in the environmental of deposition. Okay, that's one important point. The association of such rock beds which were formed under contrasting condition indicates the presence of an unconformity. As for example, let's say non-marine beds overlain by a marine beds. There is a non-marine beds, that was the old ancient rock bed on which you have marine beds. So difference in the environmental of deposition, you can also identify the unconformity. Then relation to the intrusive and all. So read this in details. Details from the study material, I will send it to you. Okay. From there you will be reading this in details. Okay. So up to this is your mid-semester syllabus. Okay. So whatever I told you to read, whatever the materials I have provided, or the PPT, whatever I teach you, that will be included in your mid-semester syllabus. That's included in your mid-semester syllabus. Okay. So we have completed the structural geology part. In your next class, I'll be talking about dams and reservoirs. Okay. And the geological aspect of from the geological point of view, or from the engineering geological point of view. So your next unit will be engineering geology. Okay. And your last class before mid-sem will be on Tuesday next week. So Tuesday you have a combined class. That will be your last class before mid-sem. किसी को कुछ पूछना है तो अभी पूछ सकते हो.